Welcome to the GMAT Strategy Podcast. You're here because you believe there's a better way to study for the GMAT, and so do we. We created the GMAT strategy to maximize your results and minimize your effort so you can get to the fun parts about business school and life as quickly as possible. My name is Isaac Puglia, and I've been teaching GMAT classes and tutoring privately for the GMAT for over a decade, and I've achieved a 99th percentile GMAT score and helped thousands of students get into the business schools of their choice. I'm excited to be a part of your MBA journey since we all at TGS believe that our world can benefit from the best possible business leaders that we can find. If this show is bringing you value, please share it with your friends and family who are studying so that together we can make this process as easy and as painless as it can possibly be. Let's go. Welcome to Real GMAT Problems, episode 45. Doing real GMAT problems is one of the surest ways to make test day go well, so let's talk through a few examples. The problems that we're going to go through are from the 11th edition of the official guide for GMAT review, and you can web search them if you'd like to follow along visually. Just so you know, the 11th edition of the official guide is out of print, and that's partly why I'm going through questions from that book, because that way, if you purchase this year's official guide, there shouldn't be any overlap between the questions that we're going to work through here. The official guide contains retired problems that have appeared on past GMAT exams, so these are going to be super similar to what you're going to see on your official GMAT. I'll give you a chance to work through the solution on your own if you want, and then I'll discuss my thoughts on what to take away from each one. I recommend pausing after I read through each problem and trying to solve it, or at the very least, visualize how you would solve it. You might not be able to execute all the steps in your head if you're on the go, but just do your best. If you are in a situation where you can physically write down what you would on test day, that's definitely ideal. We're going to start with a lower difficulty level warm-up problem, and then we'll bump up the difficulty level from there. We're going to go to a bit higher difficulty spectrum than we have in the past. So if you find yourself struggling at any point, you might want to go to an earlier, lower numbered episode and work your way up to this level over time. Today, we're going to focus on algebra, specifically what to do when you're stuck on algebra questions. This is problem number 1. The problem says if the absolute value of x is equal to the absolute value of y, and x times y is equal to 0, which of the following must be true? I'll read that again. If absolute value of x equals absolute value of y, and x times y equals 0, which of the following must be true? Option A is x times y squared is greater than 0. So just to be clear, that's not x times y in parentheses and then square the whole thing. It's x by itself times y to the second power. So it's just y being squared there. So x times y squared greater than 0. B is x squared times y by itself. So x is being squared, y is by itself. So x squared times y is greater than 0. Option C is x plus y is equal to 0. Option D is x divided by y plus 1. So it's x on the top of a fraction, and then y plus 1 is the denominator of that fraction. X over y plus 1 equals 2. And option E is 1 divided by x plus 1 divided by y equals 1/2. So it's the fraction 1 over x plus the fraction 1 over y equals 1 over 2. Again, I recommend pausing here and getting as far as you can on your own. It's a really good warm-up problem for a couple reasons, actually. It's a good example of some of the alternative algebra style questions that the GMAT likes to throw at us. And what I mean by that is we're used to solving equations when we see algebra, like isolating a variable using the rules of algebra. And there are plenty of times when doing that makes sense. We've actually talked at length about standard approaches to algebra on the pod, and we've even got several math basics episodes on that topic, as well as many real GMAT problems episodes, where we've talked about some fairly intricate equations. I would recommend just searching the feed for algebra and equations if you want to find some good approaches to more standard equation type situations. This one, I want to specifically focus on stuff that's a little different than the standard down the center, hey, here's an equation and solve it kind of deal. What's interesting is that I've found that most people don't struggle heavily with typical algebra type questions. Certainly there's going to be a handful of you out there who just were never great at algebra, maybe didn't have the best algebra instruction when you were younger. But I found for folks like yourself, if you put in the time and work hard at it, like those algebra skills will be there for you. This type of question, just like the other ones that we're going to work through today, I think it's a little bit different. And I think solving with algebra the old-fashioned way, it's either going to be really tough or just like a bad idea, because gauged against alternative approaches, it's just going to be really slow and maybe confusing. Now, as I always say, if the way you're currently approaching these questions is working well for you, then just keep doing what you're doing. But if you want to explore some alternatives, or maybe just consider some alternatives when things get weird, I'm hopeful you're going to find today's discussion really valuable. I want to start by considering what to do if you get stuck on questions like this, because the odds are if you knew how to start this question with algebra, or you knew how to operate on it well using standard algebra, like isolating variables, you probably just didn't struggle with the question at all. But I have also seen a good number of people make a great algebraic start on questions like this, and then they just get stuck partway through the solution. And we've all been there. Remember, you're here to learn. Like, this is one of the best places that you could be making mistakes and getting questions wrong, because every question you get wrong in practice is probably something you're going to get right on test day, assuming you have a good review process, and we'll talk about that later. But let's give you some tools to use if the going gets tough. One of the best alternative approaches you can employ when there are variables in the answer choices like we have here is inserting a number, or what I've called plugging in numbers in past episodes. So if you want like a ground up build, discussing the step-by-step process of plugging in numbers, if the way I'm talking through it today is not quite landing, we've got an episode titled literally Plugging in Numbers. It's from a few years back, and I think you'll find that helpful if you want to listen to that and then come back here. So this may or may not be the best default approach. And by the way, if you're on a streaming app on your phone and you're not sure how to search the feed, just go to the page where you're seeing all the episodes and just pull down on the page a little bit, and it should give you a field at the top to search the feed, or search this podcast, or something like that usually works well. And don't hold me to that if it's been like 5 years since we published this, because who knows what's happening with software on that timeline. Okay, but we're probably safe for the next, let's call it like 12 months. So this type of plugging in approach, it may or may not be the best default approach, meaning like the thing that you always do on problems like this. But again, let's just assume you're stuck and therefore unsure how to proceed. Like your initial approach did not work. Just start plugging in some numbers in an organized way and see what happens. For example, I'll make a couple columns here, one with X at the top and the other with Y at the top, to make sure I don't get mixed up about what's what as I get further down the road. So really, really simple organization technique, just columns. The problem starts by telling me that absolute value of X is equal to the absolute value of Y. So I'm thinking of putting in some equivalent values, because they have to equal each other. And maybe experimenting with different combinations of positives and negatives. That tends to be a good way to go if you're plugging in numbers on absolute value questions. Because if you think about like what are the concepts that they might be testing me on when there's an absolute value in the question, you're probably thinking like positives and negatives. That's kind of like the key thing that happens with absolute values in general. And on a test where it's partly about my math skills, but also like partly about my reasoning skills, which sometimes could be like a euphemism for like just trying to trick me and get me to miss stuff that I might normally get right in other situations. Depends on your viewpoint, of course. I won't take sides on that one today, but it's up to you to decide what's happening here. So on a reasoning test where they're trying to test my reasoning abilities with absolute values, they're probably testing my ability to think about positives and negatives. So it's just a good thing to put in your back pocket when you see absolute values and you're going to plug in some numbers. You might think different combinations of positives and negatives, but that's getting a little ahead of ourselves. So let's just start simple here. I'd probably start with numbers that feel easy to work with and compute. So 2 is like generally a good place to begin, unless unless it says that numbers are odd or something like that, where there's an obvious constraint that prevents 2. But here we're totally allowed to use 2. In fact, it doesn't constrain the numbers we can plug in at all. So we could plug in anything we want. So I'll just make x2 and I'll make y2. And I'll write those under my x column, I'll write 2, and under my y column, I'll write 2, just to keep track of what's going on. So probably to the right of that x column and y column where I'm tracking what numbers I've picked, to the right of that, I'd put absolute value of x equals absolute value of y to make sure I'm sticking to the constraints of the problem. And then to the right of that, I would put the other constraint, which is x times y has to equal 0. Those are the two conditions we've been given in the problem. Now, if I plug in 2 for x and 2 for y, perhaps obviously I can satisfy the absolute value of x equals absolute value of y requirement. And also maybe obviously I will not satisfy the x times y equals 0 requirement. So I'm going to want to think about that a little bit deeper, but it's a good time to make a point, which is when you're plugging in numbers, sometimes the reason you're plugging in numbers is you don't understand the question, hence the topic of today's lesson. Like, what do I do if I'm stuck? What do I do if I'm confused? Sometimes plugging in some numbers that don't work with what's happening in the question can still be super valuable because it can get you thinking a little bit more deeply about like, okay, what's happening with the math behind the scenes here? That might not make a ton of sense right now, but I think as you try out the technique a little bit, especially when you're stuck, you'll start to feel what I'm talking about there of like, oh, okay, yeah, I'm starting to get like a better grip, a better intuition about what I'm really being tested on here. A lot of times when I'm working with folks one-on-one and they're getting stuck in questions, I'm like, hey, why don't you just plug in a couple numbers, see if that can help you reason through the logic a little bit, or like bring the logic to the forefront. And it's not a 100% thing, perhaps, obviously, but it's nice. It's a lot better than having nothing and being dead in the water. So here I'll think a little deeper. I might try -2 for x and +2 for y. That, of course, satisfies absolute value of x equals absolute value of y. If you're just starting out and you're jumping right in with this episode, everybody, we've got a whole math basics series on absolute values. If it's been a little while since you've thought about absolute values, and there's no calculator on the GMAT quant section, so it's a good idea to go through that whole math basics series if you're just beginning, because you might just be a little bit rusty on long subtraction and long multiplication, for example. If you're like most adults walking around in the professional business world, you're probably not using long division very often. So satisfies my absolute value x equals absolute value y equation, but still does not satisfy x times y equals 0. Now you might be thinking, how does this help me? But when you're stuck, again, knowing what doesn't work can often lead you to what does work. Maybe a little counterintuitive there, but again, if you experiment with it enough, I think you'll find that to be very true. So this question is a good example of that, because if I go down this path one more step and I think to myself, okay, I have to satisfy this x times y equals 0 thing, let me try x equals 0. Then when I'm brainstorming possible values for y and I'm thinking about absolute value of x has to equal absolute value of y, I'm probably going to realize that if x is 0, y also has to be 0. So let me write that in my columns here just to keep on top of my thinking and make sure I don't miss the question because of something silly like forgetting what I plugged in for y, which, I mean, it's just such a painful reason to miss these questions. And if you've been studying for a while, you've probably seen that happen more often than you wanted to. If you're like me, when I was studying back in the day, I made way too many of those mistakes before I got my stuff together. And from here, let me just start to experiment with some of the answer options, since I finally have a set of values that fits the constraints. If I plug in x equals 0 and y equals 0 for option A, I'm going to get 0 times 0 squared, which is, of course, 0, and that is not larger than 0. You might recall that option A is x times y squared is greater than 0. So if x and y are both 0, that's not going to work. So it looks like A doesn't have to be true, which is basically what quote-unquote must be true questions are really asking us. Which answer has to be true as long as the conditions of the problem are satisfied. So if I have absolute value of x equals absolute value of y and x times y equals 0, then one of these answers has to be true 100% of the time. That's what I'm trying to figure out here. Which one is it? Let's try B. And you'll probably notice that something very similar is going to happen with B. Just to refresh your memory, if you're on the pure audio feed, B is x squared times y is greater than 0. And if you want to see how I would work through these problems, you can grab this episode on YouTube. It's got some video of a wonderful TGS teammate writing on the whiteboard after the fact here. So trying to bring some method to the madness. which I appreciate, by the way. So if I plug x equals 0 and y equals 0 in for option A, it's not going to work. If I plug x equals 0, y equals 0 in for option B, not going to work. Let's try C. That's x plus y equals 0, and 0 plus 0 does, of course, equal 0. So C works. I'm just going to leave that alone for the moment. Let's look at D, because if D and E don't work, then I can just pick C and I don't have to think too deeply about it. Refreshing your memory on D, that's x divided by the quantity y plus 1. So that's going to be 0 over 1. And D says x over y plus 1 has to equal 2. 0 over 1 is 0, aka not 2. We can eliminate D. And then E asks us to divide by 0, which is not allowed on the GMAT. So it's worth saying if you're ever asked to divide by 0 in an answer option on a GMAT question, you can assume it's definitely incorrect. Having said that, even if theoretically we could do 1 over 0 plus 1 over 0, it would definitely not equal 1/2, which is what E is saying. So just in case that previous point was a little weird, you can be doubly sure that E does not have to be true. And that should lead us to our correct answer of option C, as in Charlie. Okay. So I took us down a very, very specific path there. And again, if you had a good, solid algebraic solution for this one, that's awesome. That's amazing. Probably not struggling on this kind of question. And I'm not saying this is the greatest example of when 99% of us should plug in numbers. I'm not saying that. But I did want to use a simpler problem to introduce the idea before we get into some more complex questions, and just in case you get stuck on more complex questions on test day. So, are there some clever algebraic solutions here? Yes, for sure. But when you see the opportunity to leverage those, by definition, you won't be struggling with the question. So, if I'm really going to make a contribution to you and your success here, I don't think validating what's clearly already working for you is going to qualify. Like, you're probably pretty sure what's working for you. That would be my guess. And that's why I gave you a tool for when things are not going well. I think that's going to help you a lot more than a two-step algebra approach is going to help, especially when that two-step algebra approach might not apply very broadly. That can be part of the difficulty that we're going to confront in some of the next questions here when we get into the algebra. So with all that being said, if there's something that you want to remember from that, I recommend you make a quick note to self here by texting or emailing yourself. Just pause the episode. And that way you can make a note when you're back at the desk. If you're already at the desk, now would be a good time to pause and make a note of anything you feel could be valuable for you in the future and put that into your flashcard set or your general notes to self set or something that you're looking at on a regular basis so that you're actually learning from the questions that you're doing in practice, not just completing a lot of questions without learning very much. That's a unfortunately excellent way to waste a lot of time. And that's what I did back in the day. And I'm really trying to save you that pain. If you want to know about how horrible my situation and story was, you can check out the video on our website. It's called How to Reach Your Dream GMAT Score in Half the Normal Time, which if some saintly person had made for me back in the day, would have really helped me out. So I hope it helps you too. Okay, let's bump up the difficulty level a little bit here. This is question 2. Question says, x plus 1, so it's the quantity x plus 1 in parentheses, divided by x minus 1, also in parentheses. So it's on top of a fraction x plus 1, on the bottom of the fraction x minus 1. That whole fraction is in parentheses, and we're taking that whole fraction to the second power. Okay, so it's x plus 1 over x minus 1 squared. That whole fraction squared, okay? That's the beginning of the problem, is just that. There's no equal sign or anything else. Then the rest of the problem says, if x does not equal 0 and x does not equal 1, and if x is replaced by 1 divided by x everywhere in the expression above, then the resulting expression is equivalent to blank. And then they give us 5 different answer options that could be equivalent. Okay, let me read that again, because perhaps obviously a little bit more complicated than the previous one. So we've got the fraction x plus 1 over x minus 1. The numerator is x plus 1. The denominator is x minus 1. That entire fraction is squared. Text on the question says if x does not equal 0 and x does not equal 1, and if x is replaced by 1 divided by x, so the fraction 1 over x goes in for x everywhere in the expression above, then the resulting expression is equivalent to blank. Option A is a fraction. Numerator of the fraction is x plus 1. Denominator of the fraction is x minus 1. That whole fraction squared. So it's literally identical to the given expression above. That's option A. Option B is the fraction x minus 1 in the numerator divided by x plus 1 in the denominator, that whole fraction squared. Option C is just the variable x squared and then plus 1. That's the numerator of a fraction. The denominator of that fraction is 1 minus x to the second power. Okay, so just x squared in the denominator as well. So C is a fraction. The numerator is the variable x squared first, and then add 1 to that. The denominator of the fraction is 1 minus just x squared by itself, no parentheses in C. Option D is another fraction. We've got just the variable x squared on top minus 1. And then in the denominator, we've got x squared plus 1. Then option E is the fraction x minus 1 in the numerator divided by x plus 1 in the denominator. That whole thing squared and then multiplied by -1. Okay, so don't worry if you're losing track of all that on the audio feed. That's okay. You can still get value out of grappling with this one a little bit and thinking about how you would solve it. Again, you might not be able to execute all your steps in your head the way you would be able to if you were writing things out one step at a time on test day. I probably wouldn't be able to. But you can still think about, okay, how would I approach a question like this? What are some of the patterns I'm seeing? Can I associate this with any questions I've seen in the past? Those are really great questions to ask yourself if you're at the gym or you're on the bike or you're in the car or something like that, and you're just trying to level up with the GMAT. Okay, recommend pausing, getting as far as you can. Excellent follow-up to the previous question because I think a lot of the same points apply. Probably even more so, since this question is a lot more complicated. Some of you may have taken the algebra route here, and I've definitely seen that work well. In about 20% of cases, people get to the right answer in a reasonable amount of time on this one using algebra. But for a lot of folks, even if they can get the algebra to work, it takes a long, long time, like over 5 minutes. That's what I've seen. About 30% of cases end up that way. And for the majority of folks who start with algebra, they get the first few steps to happen fine, and then they really struggle to connect that work that they've done to the right answer choice. Like they've done a lot of correct algebra, but their result is not lining up with what the answer choice says. About 50% of cases end up in that situation. And that's roughly equivalent to the previous question. It's just that more people get the previous question right. About 20% more of us get the previous question right. Some way or another versus this one. I have doubts about that stat, team. Just going to double check that. Yeah. 3 times as many of us missed this question versus the previous question. So I guess we need a math basics lesson here behind the scenes at TGS. I got a good podcast for you. Now's not the time to be talking trash to me, guys. Okay, so quite a few more of us missed this question. Let's put it that way. So I'm not going to go through all the steps on the algebra here because I don't think the value is going to be there. Again, if you want to hear me do a ton of algebra, just search equations and algebra in the feed, and you can listen to me do lots and lots of steps of algebra on earlier episodes. But just imagine for a sec. Let's just like imagine a couple steps. Imagine using FOIL. We've done a lot of FOIL on the pod. Again, if you're just starting out, you might want to check out the Math Basics episode on quadratic equations to reskill with FOIL. You probably remember or knew what FOIL was at some point in your academic career. Might just have to shake off the rust a little bit. Even if you do all the math correctly with FOIL, and you can correctly substitute 1 over x, you'll wind up with 1 over x squared plus x plus 1 in the numerator. And then in the denominator, 1 over x squared minus x plus 1. And where do I go from there? That's the tough thing. You didn't do any math wrong, but it still didn't yield the answer that you're looking for. It's not in the same form as the answer choices. And that can be confusing. That can be really, really confusing. So if you want to use algebra to get this question right, you would have to resist what most of our natural instincts would be, meaning you would have to not FOIL, and you would have to do the math inside the parentheses first. And even then, there's no guarantee that you're going to simplify things properly in order to arrive at the answer the way they've expressed it. Not saying you're going to do some math wrong, just saying one of the risks in these algebra questions that you run when you're defaulting to algebra or your only approach is algebra is that you do a lot of correct algebra, but then the answer choice is not in the right form. That can be really, really frustrating. The point is, even more of us eventually get stuck on this question than the previous one. That's really the point. So just forgetting about the whole FOIL thing for a second. So you may find that plugging in numbers here really helps. Let's quickly talk through the optimal algebraic approach to this question and then compare. So I'm going to quickly go over this. You can sub in 1 over x in the original fraction. That gets you 1 over x plus 1 on top, and then 1 over x minus 1 on the bottom, and then remember that whole thing's being squared. You can then find a common denominator on top. So instead of 1 over x plus 1, I'll do 1 over x plus x over x. And just check out the Math Basics episode on fractions if you want to reskill with the fraction math. And that gets you x plus 1 over x on top. Wait a minute. We got another typo there. Sorry. Just forget I said that, team. Or no, that's right. That's right. Oh, man, a story of redemption here today, everybody. Okay, so if you do that math right, that gets you x plus 1. Oh, I see why that was weird. That gets you x plus 1 on the top of a fraction and then x on the bottom. So we have 1 over x plus x over x. If we add that, if we're just focusing on the numerator here, that gets us x plus 1 on the top of a fraction. The numerator of the fraction is x plus 1, and then x is the denominator of that fraction. And then that's inside of a larger fraction where we haven't dealt with the bottom yet. So you can already see, like, for certain types of people, this is just not going to go very well. They're either not going to find the common denominator, or they're not going to think about it, or they're going to make a math mistake. And clearly I'm in that boat, to be fair. So if you perform a similar operation on the denominator, you would get x minus 1 in the numerator of that fraction, and then x in the denominator of the fraction. And again, if you've already lost me on the PR audio feed, that's okay. That's okay. Probably wouldn't recommend doing the question this way unless you're like, oh, this is amazing. I love this approach. So then we can divide the fractions. Dividing by a fraction is the same as multiplying by the reciprocal. So we would get x plus 1 over x times x over x minus 1. And that's all inside the parentheses that are being squared. So we haven't squared anything yet. Then the x cancels on the top and the bottom, and we wind up with x plus 1 over x minus 1 inside the parentheses, and then that is being squared. And so we actually get exactly the same thing that we started with, which is option A, as in alpha, and that is the correct answer. Now again, if you can see from the beginning that the FOIL approach is going to be bad, and then make the required adjustments, and then execute that math without making a mistake, that's amazing. That is truly, truly awesome. And all of those skills are definitely worth practicing and developing, because a lot of times that is the best way to do one of these questions, and it's good to at least be able to do one of those. But again, going back to the point of the previous question and this episode, what if you get stuck? What if you start trying to execute that way and you just don't see the next connection? The next step just is not jumping off the screen at you. Happens all the time. That's a great time to plug in a number. You've got variables in the answers here. Let's see what happens if we go that route. So let's plug into the original expression. And let's see, what would I choose? I'm just going to go x equals 2 again. It's a really, really good default. Again, if the problem doesn't say like x has to be negative or x has to be 0 or something like that, obviously obey those constraints. But if it just says x has to be positive or something like that, I think in this question, we just say x is not 0 and it's not 1. Okay, great. I'll make it 2. So unfortunately, we had a significant tech issue during this portion of the video the other day. So I'm back in the studio and we're just going to film this for you real quick. So let's say that you're stuck. You decide to plug in a number. Let's choose something that will make the computation simple, like x equals 2. So I'm going to plug that into the original expression first. And recall that in the original expression, I need to replace x with 1 divided by x. So instead of just plugging in 2 to the original expression, I'm actually going to plug in 1 over 2 as if I'm plugging in 1 over x. And on top, that's going to get me 1 over 2 plus 1. And on the bottom, it's going to get me 1 over 2 minus 1. And of course, the whole quantity is squared. I want some common denominators there. So on top, I'll do 1 over 2 plus 2 over 2, and that'll get me 3 over 2. And on the bottom, I'll do 1 over 2 minus 2 over 2 to get negative 1/2. So my fraction would be 3 over 2 and then divided by negative 1 over 2. And that whole thing's squared. Once again, when I divide by a fraction, that's the same as multiplying by the reciprocal. So I'll multiply 3 over 2 by negative 2 over 1. And that gets me negative 6 over 2. Again, feel free to check on that Math Basics fraction episode if it's been a while since you've multiplied some fractions. And negative 6 over 2 is negative 3. If I square that, I'll get positive 9. And at that point, I can then start testing the answers and seeing if any of them equal positive 9. So let's try A. Now, keep in mind here in the answers, I'm actually plugging in x. I'm not plugging in 1 over x. The question's asking if I plug in 1 over x to the top thing, what's the equivalent expression on the bottom? Not putting in 1 over x, just putting in x. So I'm actually going to plug in 2 for A. So that's going to be 2 plus 1 on top, and it's going to be 2 minus 1 on the bottom. And that gets me 3 divided by 1 squared. Recall that option A is literally the same expression as what's given to us before. So we've got 2 plus 1 on top, 2 minus 1 on the bottom. 3 over 1 squared is 9. And that's great. That's a match. So I'm going to keep A. And then apparently the tech issue just resolved at this point. So I'm going to kick you back over to the original recording. Let's try B just to be safe. And that's going to get us one. I'm not going to re-go through the math. Well, let's go ahead and do it. Let's go ahead and do it just in case it's helpful. So B is x minus 1 over x plus 1 squared. So that would get me 1 over 3 squared. So obviously that's not going to be 9. 1/3 times 1/3 is not going to be 9. C is x squared plus 1. So that's going to be 4 plus 1. That's 5 on top. Over 1 minus x squared. That's negative 3 on the bottom. Obviously that's not going to be 9. D is x squared minus 1 on top. That's 3. And then on the bottom, I have x squared plus 1. That's 5. 3 over 5 is definitely not 9. And then the last one's negative. So no matter what I do, E is going to be negative. So there's no way that's going to equal positive 9. So where does that get me? Gets me to A. Let's reflect on that for a moment. Which way feels easier for you to execute? I know that maybe we are not going to make this question, quote unquote, easy for some of you, maybe a lot of you. But we can make it easier by having good default approaches and good backup approaches. That is the ideal situation when you're entering into solving one of these questions. Hopefully you've got something you're comfortable with, that you lean on, that you know works most of the time. And then if that does not work for any reason, hopefully you've got something you can fall back on and still get the question right. That usually goes really, really well in the quant section. In fact, which of these feels easier for me to execute is always a good question to ask ourselves after working through multiple approaches to a question like we just did. It's also good to ask yourself, in what different situations might I use each approach? It's kind of a bonus question. And some of you might default to plugging in numbers when you see variables in the answer choices. Maybe that approach just felt way easier, made way more sense. Maybe you're like, man, I'm sold. Sign me up. I'm doing that. Others of you might have felt the algebra was easier, or maybe you want to start with algebra and then pivot to plugging in numbers, or maybe you just wanted to plug in numbers for a couple options. There's no right or wrong here. It's all about what's going to help you get the best results in your situation, the way your brain works, the way you like to manage the exam. So try to judge these strategies based on the results they produce for you. I guess we should judge all strategies that way. Having said all that, I have found that at the very least, plugging in numbers is a great way to go if you find yourself getting stuck on algebra questions. Quick aside, if there are not variables in the answers, plugging in numbers may not work. You still might be able to use it to wrap your mind around the question, like I was talking about earlier, but it might not get you all the way to the solution. But the great news is if you do see variables in the answer choices, plugging in numbers is for sure an option. So you can lean into that. Okay. Hopefully, at the very least, we've given you a backup approach here. and maybe even given you a good frontline approach for questions that are similar in the future. So as usual, I'd recommend pausing, making any notes to self that you feel could be helpful, and then we'll finish one final problem that's a little bit tougher. This is problem 3. The problem says, if x and y are positive, which of the following must be greater than 1 divided by the square root of, in parentheses, x plus y? So I'll read that again. If x and y are positive, which of the following must be greater than, and then we get a fraction. 1 is the numerator of the fraction. And the denominator of the fraction is x plus y in parentheses, and then you're taking the square root of that whole denominator. You're not taking the square root of the whole fraction, just the square root of the denominator. So it's 1 over square root of the sum of x and y. Okay, so that's our question. And then we get 3 Roman numerals that we're supposed to compare with here. Okay, so we're saying which of the following must be greater than what I just read. Roman numeral 1 is numerator, square root of sum of x and y, divided by denominator 2 times x. Okay, so square root of x plus y over 2x. Roman numeral 2 is the square root of x individually, added to the square root of y individually. That's the numerator of a fraction. The denominator of that fraction is x plus y. Roman numeral 3 is the square root of x on its own minus the square root of y on its own. That's the numerator of the fraction, is root x minus root y. The denominator of the fraction is x plus y. And in these Roman numeral questions, I'll read all those again in a moment, the answer options are going to be some combination of the Roman numerals. So option A here is none of them are greater. Option B is only the first Roman numeral is greater. Option C is only the second Roman numeral is greater. And I'll come back to those in a second, okay? D is 1 and 3. E is 2 and 3. Okay, so Roman numeral 1, numerator of the fraction, sum of x and of y, x plus y in parentheses, the square root of that whole numerator. Square root of x plus y on top. On the bottom, just 2 times x. Roman numeral 2, square root of x plus square root of y is the numerator of the fraction. Okay, I've got root x plus root y, both being square rooted independently. And then the denominator of that fraction is x plus y. Roman numeral 3 is square root of x minus square root of y. That's the numerator of a fraction. Denominator is x plus y. And again, if you'd like to see these, you can get it on YouTube, and just shoot us a DM if you want us to add video to the podcast feed. I've found some people like the video podcast thing. Some people just like the pure audio thing. Let us know. Let us know if you have a preference on that. Option A is none of the Roman numerals are greater. Option B is 1 only is greater. Option C is 2 only is greater. Option D is 1 and 3 are greater. And option E is 2 and 3 are greater. Okay, so get as far as you can there. Again, if you're on the go, couldn't hold all that in your head, that's okay. Just think about, how would I strategize here? What might I do? What might be appealing to me? Have I seen questions like this in the past? One more time, I'd recommend pausing here and getting as far as you can. Okay, quite a bit more complex than either of the first 2 questions here. And that's definitely reflected in the accuracy numbers as well, with about 35% more of us missing this one versus the previous one. Let me check that as well, since we had an error in the earlier stat. Okay, so let's see. Yeah, that's right. That's right. Thanks, team. Got me covered. I love it. So clearly, it's a more difficult question for us as a group. Not a huge surprise, since Roman numeral questions like this one are effectively like 3 questions in one, and we need to get all 3 of them right, or our odds of getting the whole problem right go way, way down. But what I find really interesting here is that most people who I coach to plug in numbers on a question like this end up getting it right faster than the 2 previous questions. So not only is their accuracy about 40% higher, they're also about 60% faster than those who choose algebra here. Now, I'm not saying that's you. I'm just saying that's what I've seen. So again, if you're loving algebra on a question like this, keep doing what you're doing. But if you get a little lost, or you get stuck, or you didn't feel like you had the speed that you wanted with your algebraic approach to this one, it's a great time to plug in some numbers. And it's a little bit different than the previous questions with the whole Roman numeral thing. I wanted to address that specific situation because it's only the Roman numerals that have variables, not technically the answer options. And I found that some folks can get a little confused by that. So another trigger that you can use for plugging in numbers, if you're a little unsure, is the phrase must be. You may recall we saw that in question 1 earlier as well. Anytime you're asked for something that must be true, that's a good time to plug in numbers. I'm actually not even going to deal with the algebra here because it's really a bear, in my opinion. And much like the first question, if you rocked this one with the algebra, you probably don't need very much help on questions like this at all. But suffice to say, it's a worthwhile review strategy in general to at least attempt to understand the algebra behind these kinds of questions as you go forward, even if you don't plan to use algebra as a strategy on these questions on test day. It's just a good workout for your algebra skills to at least try the problem with algebra, reflect on how would I solve this if I had to do algebra. Really good exercise for future unseen questions. Having said all that, let's explore what plugging in numbers could look like. I'd like to use numbers that make my computation as easy as possible, like I did before. So looking at the original expression, 1 on the top of a fraction and the denominator of the fraction being square root of x plus y, I would like to get a perfect square under the square root there so I can deal with an integer in the denominator there. And so I'd probably just select x is 2 and y is 2. Going back to the constraints, all we're told is x and y are positive. Maybe I could have even gotten away with like 1 there for x and 1 for y, but then I'd get root 2 in the denominator. I'm not feeling as good about that. So I'd stick with x is 2 and y is 2. And just again, on the clear scratch work thing, which I've harped on so much in the past, I'd just write x equals 2, y equals 2. And that creates a perfect square under my square root in the denominator there. That gets me 1 divided by square root of 4, because 2 plus 2 is 4. And that's going to be 1 over 2. So that gives me a fairly simple fraction to deal with when I'm comparing to the Roman numerals. So now I'm going to plug into the Roman numerals and see which ones are bigger than 1 over 2, because that's what the question's asking me. First one works out pretty well. You might recall that Roman numeral 1 is x plus y and then the square root of that. So I'd get root 4 on the top. And on the bottom, I have 2 times x, which would just be 2 times 2. So that's going to get me square root of 4 on top. That's 2. On the bottom, 2 times 2 is 4. So I would get 2 over 4, which is exactly 1/2. So apparently, Roman numeral 1 does not have to be larger than the original expression. And that's what the question's asking, and it must be true. Which one has to be true 100% of the time? So Roman numeral 1 does not have to be true 100% of the time. It's, in this case, when x is 2 and y is 2, it's actually equal to the given expression. So that's great news, because now I can eliminate any answer choices that have Roman numeral 1 in them. So I'm going to go ahead and eliminate B, and I'll also eliminate D. Let's try Roman numeral 2. That's a little bit weirder, because I can't easily get rid of the square roots with my numbers. So I'm going to have root x plus root y on top. So I'll have root 2 plus root 2. And then on the bottom, I've got x plus y. 2 plus 2 is 4. So I'd wind up with root 2 plus root 2 over 4. But let's just say I add root 2 plus root 2 in the numerator to get 2 times root 2 in the numerator. So it'd be 2 times root 2 in the numerator divided by 4 in the denominator. Then I can cancel the 2 in the numerator with the 4 in the denominator. And that would get me square root of 2 over 2. Again, scope the math basics fractions lesson if you want a little upskilling on fractions, if it's been a minute since you canceled some stuff. So root 2 over 2. This is a great situation if I've memorized an approximation for square root of 2. And just side note, it does come up a good amount, and it's roughly equal to 1.4. So it's definitely worth knowing. Probably get a lot of mileage out of that. But even if I did not know that, I can probably figure out that it's going to be bigger than 1. Square root of 1 is exactly 1. So it's very likely that square root of 2 is bigger than 1, even if I didn't know the exact value. And if I'm trying to figure out if root 2 over 2 is bigger than 1 over 2, which you might recall is the original value for the given expression, I could probably conclude that root 2 over 2 is larger than 1 over 2. I could probably figure that out, even if I didn't memorize that root 2 is approximately 1.4. So I won't eliminate 2, because at least it can be larger. I'm not 100% sure if it has to be larger, but it at least could be larger. So I'm going to leave that be, and I'll try Roman numeral 3 now. This is interesting because now I get square root of 2 minus square root of 2 in the numerator. Of course, that makes the entire fraction 0, and that's clearly less than 1/2, so I can eliminate any options that have Roman numeral 3 in them. So we'll go ahead and eliminate e. So now we've eliminated b, d, and e, based on the fact that Roman numeral 1 and Roman numeral 3 do not have to be larger than the original expression. So I only have to choose between a, which is none of them work 100% of the time, and c, which is 2 works 100% of the time. Now, Roman numeral questions tend to be time intensive. So at this point, if you're short on time, you can just make a bet. 50% odds of guessing right here are a lot better than where we started, which was 20% odds of guessing randomly. So that's not a bad return on our time so far. But also consider that if you wanted to use algebra and you had time, you could now implement that algebra on only one of the Roman numerals, which would be probably quicker than trying to do it on all three. It depends on your algebra skills and where you're at there. So that could be a great mixed approach if you're into that. Also, if you had the time and you're comfortable testing a few different values, like plugging in 3 for x or plugging in 4 for x or plugging in 16 for x or whatever, and you have that time, then you could build your certainty that Roman numeral 2 is always going to work by testing a few more cases. But that is one of the pitfalls of plugging in numbers when there's a none option. Most of the time, there won't be a none option. But if there is one, you may not get 100% certainty. So there's a little bit of risk there. Now, it's up to you whether you're willing to incur that risk, but I can say confidently that I've very rarely seen someone miss this question when plugging in numbers. Very, very rarely. They might be stressed out about it. They might not be 100% sure, but they'll generally get it right. And just for the record, 2 does always work. So the answer is C, as in Charlie. Okay, so let's step back and evaluate. How much harder is it to get to 100% certainty on a question like this versus quickly getting to 80% certainty? Think about that. What would it take to get 100% certainty versus what would it take to get to 80% certainty? And then maybe you just mark it and return at the end of the section if you have extra time. Something to consider. I'm not saying you should personally do that. All I'm saying is that it would be great to have that option just in case. It's kind of a bummer when you look at it and you're like, well, I can't do algebra here, therefore I cannot do the question. That's kind of a bummer. And that's why I'm emphasizing the plug-in numbers approach. Sure, it's not for everyone, but it is a great tool. And I don't see a lot of programs teaching how and when to use it very well, unfortunately. So hopefully I've helped you out there a bit. At the very least, hopefully it was good to get some practice in and also have the chance to consider what you might choose for each approach and when you might implement each approach. Hopefully you got some value out of that as well. One final time, I recommend pausing there and making any desired notes to self for what you'd like to remember from that problem. If you have questions about anything we have presented here, you can reach us anytime at the GMAT Strategy on current social channels if you want to DM, or you can email us. Our public email address is contact, CONTACT, at thegmatstrategy.com. As always, my greatest hope is that this material will make your studies as easy and as painless as they can possibly be. If you want more tips and strategies for optimizing your performance on the exam, please head to our website, thegmatstrategy.com, which is linked in the description of this content, and check out our free video on how you can reach your dream GMAT score in half the normal time. In the meantime, this is a regular show, so please subscribe and please stay positive and stay consistent with your studies, everybody. Talk to you all soon.